All right, folks, welcome back. This week we're going to do some thunderstorms and some lightning and hail. So, thunderstorms, usually there's 2,000 occurring at any given time during the day around the world. Now, we all know it takes certain weather conditions for those to form, so they're less likely to be where anybody's having winter weather, more likely to be during where there's heat of summer. The U.S. is over 100,000 annually. Again, we know they mostly occur in winter, and there's certain places in our country where they're more prevalent than others, again, due to the heating and the cooling of the air. And 16 million occur each year worldwide. And here's a map that shows roughly where you may see them as far as occurrence per day. And we're in the green section on most, and it's a pretty high area. Look on the west coast, due to the marine air blowing in off the Pacific Ocean, less chance of having there. All right, the formation of thunderstorms. What does it take to get these things to get to that unique shape that they have and prevent all that or create all that chaos that we're so used to? They're formed from the rapid uplifting of warm, humid air. Warm air is way less dense than cool air. And when that air rises up from the heat of the sun and the heat of the day into a cooler air above, it rises rapidly, causing condensation, clouds, and of course precipitation next. So types of storms. We have single cell, a storm that would be localized, form quickly, and fade away just as quick. Multi-cell, cluster, and squall line. Typically when a cold front's coming through an area, you have a long line of storms. Some are more intense than others. Some places may not have any. A supercell is a very large storm that can create lots of damage with straight line winds, tornadoes, and hail, and cover a large area. All right, single cells, usually occurring in the late afternoon, early evening. Short-lived, 20-30 minutes. They blow up, they dump all their moisture, then they can fade away just as fast as they were formed. A lot of times you can actually see the individual cell from a distance, and you see the distinctive shape of the anvil cloud. A multi-cell cluster and squall line. Several storms are connected together and at different stages, forming in front of a cold front from the lifting of the warm, moist air over the cold, dry air, or from single cells that mature and intensify. So as a cold front comes through, it's a pretty steep line of cool air moving in, a very vertical shaped line. So the air can lift quickly along that front passage, lifting the warmer air high into the cooler air above. And it can last for several hours. Each cell could fizzle out, but new ones will form around it. And if you ever watch a radar over an hour or two, you can see different cells getting larger, some shrinking, but the line continuing along as long as there's the heat of the day there. And it can produce severe characteristics: hail greater than 3/4 of an inch, wind gusts 57 miles an hour, damaging lightning, downpours, and tornadoes. All right, so here's some physical parts of a thunderstorm. What happens is the warm air from the front, let's say, moving in, forces the warm moist air up into a cooler air above, top of the troposphere. The air is pushed forward into that anvil shape. You get that point of clouds, very high level cloud pushing forward through the storm. The wind behind, it could be a dry air, like a cool front coming through with a very vertical shaped front, moving the air straight up into the upper atmosphere. And then you have the cool air rushing down. So if you're outside during the beginning of a storm, you might be standing way out front here. You'll feel cool air blowing in right at the beginning of a storm. And then you might see a roll cloud. And I'll show you some examples of this in a little bit. But the cloud's sort of rolling at a lower level. It looks like just a round, tubular shape of cloud spinning. And we've had that in our area already. And of course you get hail and rain. Usually the hail will be earlier in the storm than at the back end. And there's a storm you may see. We've had, in fact, last summer was a great summer. If you're a weather watcher, we had a lot of single cell storms like that in our area here in southeast PA. All right, supercells, similar to cluster thunderstorms, but more severe, more intense. The storm has rotation called a mesocyclone. It's larger, it's actually spinning around, not like a tornado, but a large cloud mass that spins. And I'll show you some pictures in a moment. And here's one from a distance. It's not moving, of course, at this moment, but it's just a large round shape. And inside there may be tornadoes, and hail. Again, here's some supercells examples. You'll see if you're watching a radar, you're going to see them large with red in the center, circular in shape. And these little tail hooks down here could be tornadoes, perhaps. You could call them little hooks in the radar. Actually, a tornado will show up on there with a skinny little line like that. Here's a supercell, and you can see the rotation going counterclockwise as viewed from above. And you can see the roll clouds that are also forming here. And in the lower part of the picture, you can see the precipitation coming down. And you can see the sheets of rain as the storm develops. This is a great picture that shows the roll cloud right here. You can see it rolling as it's coming towards you, and the lightning bolt shooting down to earth in between. And eventually you start to feel the cool blast as it comes in towards you. Here's another picture that shows the roll cloud coming at you again, and the precipitation in the distance. Just a good picture of lightning. Again, these are time lapse, all these to show the motion, and this one just shows the anvil cloud going off to the left as the cloud billows up towards the top of the troposphere. I've assigned this thunderstorm simulator, and I've asked you to do a few questions from it. So it has three variables that you can change. On the left-hand side, high level temperature. Again, that's the temperature way up the top of the troposphere. The amount of humidity, again, this refers to the lower levels. And then the low level temperature. This is where we are, down there on Earth, where the sun's baking and creating heat. And what I'd like you to do is rearrange those sliders. They slide from to the left or to the right for all three of these variables. And I want you to answer three questions for me. So as you adjust those settings, there's a go button there, and it'll either make a storm for you or it will not make a storm for you. You'll see it develop in the middle of the screen. I'd like you to give me the conditions for the high level temperature, the humidity, and a low level temperature for a small, medium, and large storm. So in the Google Docs I provided for you, I have small storm conditions, medium storm conditions, and large storm conditions. Just give me those three conditions that are required for each of those to form, and then submit that to me. Thanks.